on.
Okay.
Good morning, Titi.
Good morning.
Good morning, everybody.
Good morning.
Good morning. Good morning, Jean-Philippe and Michel. We are going to begin in 1 minute now.
Morning.
Hello.
Good morning.
Good morning.
Okay, it's now 10 o'clock in Finland and 9 o'clock in France. We are still waiting for some more participants, but let's start slowly with the practical things. So first of all, I want to welcome you all in this AI in Grids webinar, which has been organized jointly by Smart Otaniemi, Think Smart Grids, and Business Finland. My name is Tytti Nikunen. I'm a communication specialist at Smart Otaniemi, and I will be guiding you through this webinar. About the practicalities, first of all, we will be recording this webinar, and all the materials will be available afterwards. And we kindly ask you to keep your microphone muted when you're not speaking. And in case you have any questions, please don't hesitate to write them in the chat box. We have reserved some time for the questions after the presentations. And if you want to address your question to a specific speaker, just write their name in front of your question. My counterpart in France, Cécile, will be sharing the slides. And in case you have any questions about the practical side, please don't hesitate to write that in the chat box as well. We will do our best to help. So Cécile, we could start with the agenda so that everyone can see what's going to happen next in the webinar. So thank you very much. So as you can see, we will start with a short introduction and then give the stage for our brilliant specialists who will share their AI knowledge with us. And as mentioned, after the presentations, there will be some time for questions and discussion. So that was the boring part, and now it's time to really begin. So please, Valerian and Sanna, feel free to start the introduction as soon as you're ready.
Thank you very much, Tuti. Welcome to everybody. My name is Valérie Anne Langsnaar. I am the Managing Director of Think Smart Grids, and I am very happy to share with you today all these presentations around the AA and to have some use cases between France and Finland. First of all, I would just say a few words about our association in order that our Finland colleagues understand who we are and what we are doing. So, Cécile, you can put all the info that are on these slides. Thank you. So we consider that the global market of smart grids in the world is about 100 billion euros, and that France is taking about 10% of the global market share. So in Think Smart Grids, we have more or less 100 members. And in France, we've been implementing more than 120 smart grids demos project since more than 10 years. Each year, 100 million euros are invested in the field of R&D, and between 20,000 and 25,000 direct jobs are concerned by smart grids today. Next slide. So our association, as you can see, here are our members, and we have the privilege to welcome in our board the Energy Regulation Commission, as well as the French state, through the Directorate General for Enterprises and the Ministry of Ecology. Next one. So our association is currently chaired by Mrs. Marianne Legnaud, who is also the chair of the entities. Can you close your microphone, please? So Ms. Legnaud is the chair of the entities utility in France, which is the main one. And now, just for you to have an overlook about what we call smart grids. So our members work on these 6 topics: network management and operation, new uses that includes the integration of electrical vehicles, the co-construction of smart city networks, integration of renewable resources, role of the prosumer, use of data, and today we are on that topic, research and expertise. And now my last slide. Thank you. So in Think Smart Grids, we are convinced that IA and grids is a really big challenge for utilities and providers. So in our data and digital transformation working group, which is currently chaired by the representatives of DC Brain and COSMOTECH, we've been implementing 2 position papers about that topic. 2 years ago, we've been publishing a paper about the digital transformation of utilities. And last year, paper that you can read on our website, which is about data analytics in utilities. So I must say that we are very happy to have this webinar today, especially because a memorandum of understanding has been signed between the French and the Finnish government 2 years ago. This is a bilateral cooperation in artificial intelligence, which is focusing on different topics, but especially on the future mobility and startup ecosystem. So we are very proud and very happy to be an action in some way of this cooperation that has been signed. And I am sure that this webinar will contribute to develop active collaborations between French and Finnish companies. Thank you. Sanna, the floor is yours.
Thank you, Valerie, and very, very nice opening words. And it's been a pleasure to collaborate with Think Smart Grids. Good morning on my behalf as well. My name is Sanna Örni, and I work as a co-creation manager at VTT Technical Research Center of Finland. It's really our pleasure from Team Finland side to act as a co-organizer and continue this very fruitful French-Finnish collaboration that we have between Think Smart Grids and Smart Otaniemi ecosystems. Together, we have already been exploring the opportunities in EV charging, and now we are investigating what is the state of the art in AI in smart grids in France and in Finland. What kind of challenges AI and utilization of advanced analytics can tackle in the electricity grids? And how we as energy users can get value out of it. I am looking forward to great speeches and presentations and lively discussion today. Cecile, could I have the next slide, please? Collaboration is gold when solving the great challenges and then turning them to great opportunities. And our main organizer in this webinar from Finnish side, Business Finland, is the good gateway to concrete collaboration. Business Finland colleagues, senior advisors Sari Toivonen and Heli Pasanen-Zents would like to give a helping hand after the webinar in connecting people and companies together. I wish you all an insightful webinar, and it's a privilege to spend this Friday morning together with you all. Thank you so much. Merci beaucoup.
Thank you, Valerie and Sanna, for the great introduction. So next, we will hear some views into the state of the art in AI in grids. So we will have few presentations from the university point of view. And the first one is Vincent de Boucher from the University of Grenoble. Please go ahead.
Grenoble. First of all, thank you for attending that seminar. I hope you hear me correctly. So I'm very pleased to start this series of talks on the subjects, and my role here is to provide some context here in which the remaining talks should in fact get into in a way. So indirectly an overview, we could call that state of art, but in fact to ask some question on how and why AI could serve power systems, grids in general. So next, please. Basically, if we start with the big picture, you know that grids are drastically evolving and on many levels. You have an increasing variability on production with the integration of DER. You have non-commercial loads, local energy communities, storage. You have to manage a large variety of objects, including their aging, maintenance, planning. So asset management is as well not easy. Without forgetting the operation of that almost chaotic system, where you have to look into its safety of operators, of course, to maximize its efficiency and as well increase as much as possible the resiliency of the system, who will face at an increasing rate extreme events due to climate change or other. When you put all that together, you can see on that picture that you have a communication elements almost everywhere. Through monitoring, sensor, communication systems and so on, smart meter, advanced smart meter infrastructure, you increase exponentially the volume of available data. And at the same time, you increase the complexity of that system. All that is a land for AI at many levels, and also it is something that we will discuss right away, open as well many issues. Next, please. So if we start with opportunities for AI, the idea would be, in fact, first to be able to identify applications for which it would be relevant or interesting to, in fact, rely on additional tools, basically AI techniques. In the literature, you will see that whatever domain you consider, from distributed generation to smart consumption, including the grid as well, any kind of components, traditional and new ones with only considering electric flows, but as well information flows. In fact, for all of that, you shall be able, in fact, to discriminate applications. Within those applications, of course, it's very easy to know which one will be suited directly for artificial intelligence. Typically, it will be production, consumption forecasting, discrimination, fault detections, and you have things like that where you rely on time series and detecting prominent features that are really suited for artificial intelligence, but not all of them. And in those contexts, so typically electrical engineering and grid management, basically you will have always to keep in mind that those tools, AI techniques, will be part of a larger picture, a bigger chain of control, monitoring, and command, where you will rely not only on artificial intelligence techniques, but other elements that we master well or not, coming from other communities. Could be optimization, business models, and so on. So typically, when we use such techniques, we will not always be directly interested in the efficiency of that techniques per se, but the overall error of the system once you put everything together. Next, that leads to my third slide, or fourth, I don't remember, where in fact I show you what would be in fact the best case scenario to select a range of techniques, AI techniques, in front of a range of problems to solve. So it's a very simple illustration. You can see on the left that we have a list of basic problems that we can identify. For instance, if you are in charge of, I don't know, a dispatching center, you are operator of a distribution grid. Of course, you have to observe, control your grid. It would be nice to have some kind of forecast, eventually clean the data, estimate when you are right or wrong with your measurement. Once you have issues, problem, or you plan to have action on your grid, you will have to plan in advance that maintenance, support the decision of the operator, and so on, reconfigure the grid, or using flexibility tools if ever you have it. Those problems will have a strong operational hypothesis, typically data access, the quantity and quality of data, is that discriminated or not, and also the user involvement. Typically, an operator will already have in place tens of slides, 10 screens in front of them. So if you add more elements or more techniques, it will be difficult for them to deal with those problems depending on their frequency of the problem. In front of that, you should be able to put a canvas where you will select supervised, unsupervised reinforcement learning techniques that fits well the problem to solve and the operational hypothesis. And when you have those three put together, in fact, only you will be able to connect the relevant application to the relevant technique and put everything in a broader context using and relying on existing expertise and existing other techniques. One last point here. So I'm talking from an electrical engineering laboratory. So my expertise is on electrical engineering. So I would say understanding, modeling, and dealing with the problems that you can see on the left. My expertise by default is not on AI techniques. So it means, like we do all the time in smart grid related problems, systematically any kind of issue in academia will be dealt with by a combination of expertise. So people expert in electrical engineering, people expert in mathematics, applied mathematics for optimization, economics for use cases, and data scientists and AI techniques for advanced development of innovative tools like that. Plus industrial, in order to get the correct operational hypothesis. So when you put those teams all together, then you will be able to really put together relevant applications in front of relevant techniques. Without that configuration, that base case scenario, it is really difficult to have something more than just innovative documents for researchers amongst researchers. Next, for the conclusion, I'll try to be short and stay on the 7 minutes. Basically, so AI, I think we can see that for the moment as a future digital assistant to explore a set of features, to detect anomalies, prominent characteristics, to assess risks, possibly help coordinate and recommend actions. So typically, in the future, we could see for the grids more self-healing, more self-learning, possibly plug and play or increase automation. All that will lead to R&D works. Typically, we will have to be able to approximate model in order to reduce dimensionality and help overcome the tractability barrier of those problems, because most of the issues will be related to scalability, to algorithm efficiency, and also the stability of the algorithm under failures, which is one of the main issues. Most of the AI techniques are relevant in those contexts, in addition to more traditional techniques. And of course, last and most important, experiments are mandatory, where you consider, in fact, the human in the loop, typically a non-optimal usage of whatever you would develop, and the user satisfaction preference, the safety and privacy of whatever you can implement and put in front of people. To finish on that, regarding limitations, I told that already. Suggesting action rather than taking them, I think it's a good way to start using techniques such as AI. And to deal with large volume of data, not always available, not always clean, of quality, and that could open other problems like cybersecurity, for instance. Okay, last word, and I stop there. I already talked about the transdisciplinary history that this opens to everyone, but I wanted to say that the complexity of the two, typically, depending on the techniques of AI you use, you will be facing something that you do not understand, so some kind of black box, we say in French. And when you discuss with some person, typically grid operator, what you do not understand, basically you will not very easily trust. So this is also something to work on the pedagogy and the way you present or develop your computations and techniques to keep in mind in the upcoming works. Thank you very much. Sorry for being a little bit too late, a bit too long.
Thank you so much for this greatly informative presentation. And we will continue with an academic view on AI as Ilkka Lakaniemi from Aalto University will be our next speaker. You're welcome to start.
Thank you very much. And many thanks, Vincent, for the nice segue to my presentation. I think it's good to continue from there. So good morning and many thanks for the invitation to be part of the meeting today. I think we will have a very good discussion. So my name is Ilkka Lakaniemi. I work as a research director at the Aalto University School of Business. So what I will discuss today has from the kind of the perspective of an economist on AI and using advanced analytics for the smart grids. And I also lead a consortium of 30 largest companies in Sweden and in Finland working in the area of using data for improving their business operations. And that consortium is called Combient. And we have companies there that are also linked to the Smart Otaniemi project, like Fortum and Kone and Nokia. So the companies that are currently working in a Smart Otaniemi. Can I have the next slide, please? So what it is that we have been doing during the Smart Otaniemi project, which is actually located at the Aalto University campus in Espoo, Finland, the city next to Helsinki, is that we have very much looked into that. What is the reality of using different technologies, whether in EV charging or turning the consumers into a prosumer community of electricity. But at the same time, we have used the testbed facilities of Smart Otaniemi to really create a regulatory sandbox for various solutions that are not present in the current grid systems within electricity companies and the users in Finland, and also thinking about how we in a city as a platform, using that as a test bed for smart services, whether for the private sector companies or for the public sector as such. And a specific attention we have paid is actually on the data sharing platforms. So when we really think about the value and the added value of using data and utilization of the data in the business models, there is quite a lot that can be done fairly easily with new technologies. But at the same time, one of the main obstacles for the companies is that when we're thinking about the full value chain, how do we get the companies to share the necessary data, and what is required from the business point of view for sharing that data, and the ownership issues and IPR and the like. So what we have created is a testbed solution for data sharing and data utilization that actually enables secure and trusted transactions of the data between the players to create services that can then be scaled further on. But in reality, obviously, Finland and France share not only the MOU that was presented in the part of the introduction, but also the same challenges and the drive towards data-driven businesses and for sustainability issues. And those are very much the drivers also for the activities that we are generating within the Smart Otaniemi. Can I have the next slide, please? So what it is that we have done and where we are heading to is that you can see from this, and I will not go into the details of the roadmap, but what you will see in there that we have already completed the first phase of our activities and really work together on a simultaneous fashion, not only on the enabling technologies area, but really looking into that, what it is that we need to have to enable it from the business side and from the data side of the use of AI in not only the smart grids, but in the business modeling and other areas that are related to that. And in Smart Otaniemi 2.0, as we currently call it, we're talking about an investment close to 800 million euros, together with our EU partners and with the private sector partners here in Finland and elsewhere, where we are really looking for making the testbed even more visible and usable for various companies, whether we're thinking about AI or 5G or other technologies that will be those enabling technologies. And at the same time, we're driving this, what I refer to a business-driven, use case-driven activities within the Smart Otaniemi. So there are specific areas where we will continue with the pilots that we already had in the first phase, but we are very open to new use cases with other business sector partners as well, to really create what we call the smart and clean city solutions that then can be scaled for the European markets and the global markets as such. I already referred to that the connectivity is actually the easy part. So what we have done, for instance, with Nokia, is that we have created a 5G test bed within the Smart Otaniemi, where we have base stations put in place for the connectivity area. And at the same time, in the advanced analytics area, we are currently using the AI very much in the same way that was presented by Vincent in the first presentation, but at the same time really doing this business modeling calculations, that what it is that can be done with the data. And there I would say that one part of our activities is really talking to the companies and making them to understand that what are the realities and what you need to have in place in order to fully utilize AI or advanced analytics in the use cases. And I would say that awareness of that what in reality can be done is very much about the mindset instead of just the technology area as such. We need to do those in a parallel fashion. Can I have the next slide, please? So the main question for my research and for the activities that we are pushing from the School of Business side is that we are really thinking about that how the test bed activities that we are currently building in a business and innovation ecosystem, what is part of Otaniemi, how those smart services that are created and tested there can be scaled. And that area is where that business modeling activity plus really understanding that how do you approach the market and what type of partners you need to have in place are needed for that or are the key issues. And there, for instance, in the Smart Otaniemi, we will have close to 100 or a little bit over 100 companies working together in this area, ranging from large enterprises like Fortum and Nokia and Kone to the small and medium-sized enterprises that are needed in there to really utilize the data platform and the best practices that we are creating for sharing the data and using the data for services. And that will be done through APIs and really getting them to adopt those best practices for their ideation and service creation as such. I'll end in there, and I'm very happy to be part of the discussion at the later stage and to answer any of your questions. Thank you.
Thank you so much, Ilkka. It was very interesting to hear your viewpoints as well. And in our next presentations, we'll move from the state of the art to more practical use cases. And the first use cases come from DSOs in Finland and France. And first in line is Mikko Muurinen from Helen. Please go ahead.
Thank you. You can actually go ahead to the next slide already because we are a little bit behind time. Yeah, happy to be here. My name is Mikko Muurinen. I'm the head of data and AI at Helen. Been with the company for 6 months. New to the industry. My background is from various different companies, both in public sector and private sector, from startups to global corporations, and I've been working both in IT and in business, and now running the data and AI function in Helen. Here's some key figures from Helen. I won't go through this, but Helen is one of the largest energy companies in Finland. I like to describe us as a full stack house. We are not just a distributor, we are also producing heat and district cooling and electricity, and also heavily investing in these new energy efficient and sustainable methods. But focusing on the AI, we could move to the next slide, please. Yeah, Helen has recognized data and AI as our key strengths in the future. I had a discussion a couple of weeks ago about data and AI and our new data strategy with our C-level executives and the management team, and I kind of compared our long-term strategy to Elon Musk's Mars vision. So my vision and my team's vision is that someday everything will be run by AI at Helen. It's a bit provocative statement, but if we think about our landscape and how the energy sector is developing, it's quite easy to understand why we are coming to this conclusion. On the other hand, we are facing the change in the production side, moving from a couple of big power plants to this distributed network of thousands or tens of thousands of solar panels, wind farms, all sorts of new ways to tap into geothermic energy, waste, getting energy from the waste, and so on. So on that side, the system is becoming so complex that there's no way a human or even a large number of people can handle that. efficiently, and we need to improve the optimization and utilize AI and advanced analytics, and even regular basic analytics wherever we can. And on the other hand, we have become, during the couple of last years, more and more focused on the customer. We try to be more customer-centric than our competitors, and that creates the same problem. If we are targeting smaller segments, providing more and more individual service to our customers, there's no way a human or even a large mass of salespeople or customer service people can handle that without AI. Could you change to the next slide? We have mapped our use cases into our overall Helen map, how we are developing from the traditional way of energy production and distribution to the new world. And we found tons of different use cases to AI. And we have been piloting many of them. And during this year, we have been moving from the pilot phase to production phase. And now we are in the phase of trying to scale this thing up, how to efficiently utilize AI models in a production-like system, production-like way. So we have done a lot of optimizations in our processes. We have utilized AI, for example, to improve forecasts, for example, district heating, demand forecasts, utilizing weather data to improve those forecasts. We are using AI to predict failures, using predictive maintenance to find failure points in the grid, find components that need to be changed. And also we are moving into more and more wind production. We are starting to build new type of models to predict the capabilities there. And also not only the grid side, but also the user customer side. We are moving heavily into analyzing more about our users, how to segment our customers, how to predict their behavior, how to prevent churn, keep our customers, and also improve their living capabilities in smart living, in electric transport, utilizing AI to create new kind of services to our customers. I would like to discuss this in more detail. If someone is interested, we can discuss it later on, and you can ask me questions. But I think that my 7 minutes here is now ended. But in the Q&A part, hopefully we'll have time to answer more questions. Okay, thank you.
Thank you very much. It was really interesting to see the Helen solutions. And now we are going to continue with Enedis, as Jean-Philippe Poirier will tell more about their solutions. Please go ahead.
Do you see me and hear me?
Yes.
Okay, good. Very good. So let's get started. Well, first of all, thank you very much for inviting me over. I'm truly pleased to join in. I'm Jean-Philippe Poirier. I'm run the industrialization of smart grid solutions at Enedis. Today, I'll provide you with a quick overview of AI and machine learning at Enedis. Obviously, I will not have the time to cover it all, but I hope you'll get a sense of the diversity of approaches and the several use cases that we are tackling along the way. I'll get started with the next slide, please. Won't delve into many figures, but the fact is It's important to keep in mind that we're a large distribution system operator. We are the largest in France. We operate 95% of the grid. You'll see some key figures that are really interesting, and I'll comment back on that later on. Next slide, please. You'll see that my presentation is focused on industrial performance. I will not talk today about customer and stakeholders relationship management, no talks about chatbot and so on. I will focus on industrial performance related to the grid. Next slide, please. Very interesting fact. What you see here is essentially the whole value chain of the distribution grid. You can see on the left, starting from the primary substations, going through the secondary substations, up to the metering systems, and up to the delivery point to the end-use customer. Fact is that on top of deploying Linky, this is the name of the smart metering infrastructure that we're deploying, we're also deploying several sensors, thousands of sensors along the way. So all across the value chain, we're deploying smart sensors, and that helps us getting a very digital grid in the sense that we're collecting lots of data, and now we are able to analyze these data and make sure that we're not only observing the grid, so we're supervising what goes on, but also able to predict and also think back on what happened very precisely. So I'll probably move on to the next slide if you wish. Once again, this is the whole value chain. So from the primary substation on the left up to the end-use customer on the right, going through the medium voltage grid, the secondary substation in the middle, and the low voltage grid on the right. I won't have the time to go into detail, so I selected 3 examples. So if you click one more, thank you. There'll be one on the medium voltage grid, one on the substations, the secondary substations, and one on the low voltage grid. And if you click one more, thank you. First of all, I start on the left. There are several use cases that are based on image recognition. This is really powerful because it helps us do some things that we were already doing, but even better, even faster. First example is on the left of the overhead line equipment diagnostics. Very truly powerful because it is dealing with diagnostics. When we're building grid overhaul programs, we need to make sure that the diagnostics are made correctly, and if we can make them even faster in a more accurate way, it helps us a great deal. This is newly enabled through image recognition in this field. Also, we have on the medium voltage, low voltage substations, also called secondary substations, we're able to deploy a large program of how do we make sure that the equipments that we have in those substations are they the right ones? You know, through the life of a substation, the transformer can be changed, a switchgear can be changed. What is the serial number? What is the type of equipment? It's very important to know what goes on in precisely, because it helps us in the case of maintenance, so maintenance programs, but also investments, knowing for sure that you've got this kind of transformer in this substation, and to have it in a robust manner is truly essential to making the right investments later on. And the third example is actually something that I will use. The next slide. Yeah, thank you. Go on. Yeah, thank you. The next example is related to predictive maintenance. We do predictive maintenance on several levels, but I've chosen to focus on the low voltage side. I mentioned that we were deploying a new smart metering infrastructure called Linky. that helps us gather lots of data. And the fact is that we're observing the grid, and it's really new in the low voltage side. And the fact is that when you cross data from the metering system and you cross data from the grid information system that we already had, that helps us predict on a short-term level emergency field operations that need to take place in the field. That is truly powerful because it's a cooperation between data scientists and operatives in the field. What you see on the right is actually the way it works. It's a classic machine learning, supervised machine learning process where you get a qualified data set. You identify the prior signatures, you make sure that you get the right data, and you make sure that you get the right people that are going to be able to identify precisely what's going to be happening in the field. So later on, you get a shorter prediction that is accurate. Last slide, because my time, I believe, is over. I wanted to open up to the several fields that are really helpful in the AI for distribution system operators. If you get challenges in maintenance, challenges in optimized investments, and challenges in crisis management, well, we talked about climate change and so on. Well, truly AI is a key tool and powerful tool to use that and face those challenges. Thank you for your attention.
Thank you for a very intriguing presentation. And now, and let's try again. Thank you very much for the intriguing presentation. And now that we have heard some examples from DSOs, it is time to give the word for SMEs. Our next speaker is Michel Morvan from COSMOTECH. Please go ahead.
Thank you very much, and thank you very much for inviting me. I'm going to speak from my position of co-founder and executive chairman at COSMOTECH, and going to show what we do. Just to let you know, I used to be in a previous life a professor in computer science, university professor, specialized in a kind of AI systems. And so what I'm going to present, I will use my my two hats to share with you in particular some quite important things about AI and the way we can use it. So next slide, please. So I'm going to give you first an example of what we do as a software vendor. We are doing what we call digital twins to simulate and optimize operational efficiency. And so I'm going to talk about one of the big pain point of energy customer. When I say customer, it's our customer. So it's a big energy transmission operator, the French one, RTE. They, as a lot of them, were facing a wall of investment, meaning a lot of equipment is going to arrive at the end of life at the same time. So it means investment, rather than spending 1 billion every year for maintenance and renewal of equipment. If they don't do anything, it will be 1.2 billion next year and 1.4 the year after, and it's just impossible. At the same time, they have to adapt because their network, because of energy transition and environmental impact, how to include renewable energies. At the same time, there is an aging workforce. 40% of the employees are going to retire in the next 10 years, and they have to justify investment decisions. So we are facing with them, they were facing a very, very big problem. And I'm going to show rapidly how with AI, we succeeded to provide the software that now we sell to other players to help them make the best possible decision. So next slide, please. Well, so we created a software that is called COSMOTECH Asset that allows to simulate, compare, and optimize the whole system with COSMOTECH Asset Augment decision-making capability. So the very important thing here is to create what we did, a digital twin of the whole network of RTE. When I say the whole network, I say 1 million assets, 4 million interactions between assets, all the teams that work on the asset, when they do the maintenance, all the financial aspects, the risk, and so on and so forth. And we put all these information, meaning all the knowledge of the different experts about the different parts, what happened when there is a failure, what is how the teams are used, how is it impacting, what happens, for example, on the transformer. If there is a failure, then the line is cut. Then you can use this moment also to maintain other equipments related to this one. But at the same time, the current is going on another line, is overloading it, and the equipments are aging then. So they can also fail. So you can have cascading effects. And we put all that in a digital twin, what we call a digital twin, a simulation digital twin. So we can simulate and do what if scenarios. What if I decide to delay this investment? What if I decide to use the money I gain from delaying an investment for doing maintenance, and so on and so forth. So we have created an AI tool that includes all the information they can have from data, but also all the knowledge, all the expertise. And this tool now can be applied to a lot of other, we sold the tool to other TSOs or DSOs. So can we go to the next slide, please? So this is an AI predictive and prescriptive analytics for utilities tool. In this very case with RTE, the result is 10% of savings in OPEX and CAPEX, and a reduction of 20% operational conflicts. So remember, we are talking about 1 billion spending every year. And as I said, we have the whole network, the whole assets of the network, which are included in the digital twin. And an important quote from the French regulator, because RTE just had the negotiation with the regulator for the next 5 years, so 5 billion spending. And they say, after analyzing the method underlying RTE's asset management strategy, and in particular the simulator of asset management scenario MONA, which is the name of the tool, COSMOTECH asset, the CRE, which is the French regulator, is favorable to RTE approach to search for optimal solution over the life cycle of assets. So it's something that is quite revolutionary because it gives the visibility at short term, medium term, and long term using the most advanced AI technology. Can we go to the next slide, please? And now I want to give you, based on this example, I want to share with you a very important fact about AI. Well, first, in the world today, uncertainty and complexity are the new norm. So we have learned that we cannot know and predict what is going to happen and how to react only based on data from the past, because the future is not always like in the past. And when we are looking at our system, when we want to make decisions, it's a very, very complex environment, but we cannot only rely on data from the past. So we need more, and more is what AI also is going to provide. If we can go to the next slide, please. A very important thing to keep in mind is AI is not only based on data. When we talk about AI, everybody says, oh, data, we need data. It's based on data. But if you use AI only based on data, you will only be able to predict things that happened in the past. And you want to be able to predict things that never happened in the past, or things that are related that can live and happen in an with uncertainty. So what you need is also knowledge-based AI, which, by the way, is a very, very big part of AI, and that people forget. And this is the kind of things that I've described, in which you encapsulate in the AI software knowledge of experts, and you put them together, and then you're able to run simulations, simulating what is happening. Can we go to the next slide? So if you look, you have descriptive data, but you want to go from that to systemic actionable insight, taking the whole system into account. And you have things about the current state, but what you're interested in is visibility to make decision, the future view. Can you go to the next slide? Next part? Yes. So the first thing is data-driven AI. This is what you use with the data. It's monitoring. It's what happened now, the IoT. You can do diagnostics. And this is the first step of what we call AI data-driven digital twin. But the second part is simulation-driven AI, where you can have system prescription, what if, how to, and system prediction. And this one is really based on knowledge. It's knowledge-based AI. And this is what I presented. And if you go to the next slide, the big value comes when you do both, using a database AI, for example, for predictive maintenance of one equipment, but knowledge-based AI to make the decision about the million equipment. You have the knowledge about when they are going to fail and how you organize over time the change and the maintenance and renewal. And thank you. I'm going to stop here.
Thank you so much. And from here, we will continue with Olli Parkkonen from Nuuka Solutions. Please, stage is yours.
Thank you very much. And hello, everyone, on my behalf as well. Pleasant to be presenting to you today. My name is Olli Parkkonen, and I work as the head of business development at Nuuka. In my presentation, I'm going to tell you more about how our customers, especially City of Helsinki, the capital of Finland, can utilize our data platform and artificial intelligence in practice in order to make their assets, real estate assets, more energy efficient, healthy, and indoor climate friendly. So Nuuka is the intelligence behind healthy buildings, and we offer a real-time data platform solution for our end customers, which usually are real estate owners, developers, retail chains, or whole cities. And we collect, analyze, refine the data from different data sources in the buildings. And then our software solution offers a different use case for different individuals within the real estate organization, ranging from the owners of the building to the building maintenance people. So we help them to increase the asset value, optimize the indoor conditions, improve the energy efficiency, and save the operational OPEX in the end of the day. So today we have connected approximately 3,000 buildings to our software. And to give you an idea how much data our platform analyzes during this presentation, so basically during next 5 minutes, so it's 19,000 energy consumption data points, 110,000 HVAC building process data points, and 35,000 indoor climate data points, from different data sources in the buildings. And all this in order to help our customers to efficiently manage their real estate assets. And then a few words about, you can go to the next slide now. So next, a few words about what we do with City of Helsinki. So today, over 1,000 buildings in the City of Helsinki area are connected to our system. Those are libraries, schools, kindergartens, and so on. And as part of Carbon Neutral Helsinki 2035 program, we help them to make their city buildings more energy efficient and indoor climate friendly. And there's actually a concrete carbon neutral plan for City of Helsinki in place. And Nuuka is one of the concrete ways to reach those carbon neutrality targets on the city level. So basically we collect data from their city buildings, building automation systems, energy meters, and indoor air sensors, and bring all this data to our cloud solution and provide energy, indoor air, and process analytics to City of Helsinki. And actually with this case, we're also doing a cooperation with Helen. And City of Helsinki's energy and indoor air experts are using Nuuka to report the energy consumption, indoor air quality, and making actually sure that buildings work as they should in the first place. And it's good to know that a lot of the CO2 emissions in Helsinki are coming from the heating of the buildings, and there's actually plenty of room to reduce this CO2 figures in terms of heating. And one way to do is to digitalize your buildings and utilize the data collected and analyzed in those buildings. And another interesting thing that we are piloting with City of Helsinki is demand response. So basically we are researching how we can use City of Helsinki's public buildings as virtual power plants. And the first pilot buildings include some schools and kindergartens. And the idea is to control the air handling units and the power of those air handling units up and down on Fingrid's of FCRN market. And basically, obviously, we need to also measure the CO2 levels in the buildings and pressure differential levels in the buildings so that we don't actually ruin the indoor climate in the buildings while we do this. But we can announce more results about this demand response piloting next year. And then to the next slide, please. So I have been telling a lot about how we collect data from the buildings and how our customers can analyze it with our analytics. However, in the future, we believe that one needs to optimize the buildings automatically, predictively, based on artificial intelligence. And one concrete use case is our new AI Air concept, which is our first AI application in our series. And the basis for this new solution is that we believe that AI is the new user of buildings management systems. And it is widely known in this market that the building automation systems that control the properties HVAC processes, they are not well optimized and tuned. And actually, they don't always have the best and most educated users available. So basically, artificial intelligence automates the optimization work, and it significantly reduces the amount of needed for expertise work in the building. And when buildings move closer towards zero energy solutions, the role of optimally functioning building automation system will become more important increasingly. So Nuuk AI Air calculates all the time the optimal air volume based on the data that we collect from the buildings, and then we send new set points to the building automation systems. So this means we are not replacing the existing BMS in the building, we're just sending in more optimal set points for better impact and results. And I think Ilkka said in his presentation, if I remember correctly, I think it's a lot about attitude as well. It's not only about technology. And so, I would encourage building owners to utilize AR in this domain in the future more and more. So basically, that's how we make buildings healthy for people, businesses, and environment. Thank you for your time, and should you have any questions, please do not hesitate to contact me in the Q&A session or after this webinar. Now hand it back over to Tytti, I guess.
Thank you. Thanks for the presentation, and it's actually time for our final speaker today, as Liana Ault will tell us a bit more about the artificial intelligence at Nokia. Please feel free to start.
Thank you very much, and I'm very honored to be speaking to you. My name is Liana Ault. I am the Energy Innovation Lead for Nokia's Global Practice Team. My background is in carrier network engineering as well as telecommunications and innovation at a power utility in the US. Next slide, please. So I'm really actually reiterating what we've already heard about the grid and where the drivers for AI are coming from. The complexity and scalability of our modern grid and what we see in the future are really driving the need for efficiency and also predictability. So I'm not going to spend too much time on this. I know we're a little over. Next slide, please. So in this situation, what I really want to show is the foundational components that are necessary in order for us to make sense and make use of and practical use of the data that we collect and the algorithms that we use to create this type of intelligence. And so ultimately what we want is to create that actionable item. And by creating, basically creating this type of a platform where we have the data coming in, we obviously need a communication network to get that data where it needs to be. whether it's one single location or multiple locations. And then we have the interoperability between different systems. And this is something that we're seeing a great drive for, is open architecture systems and APIs that can then help those using the intelligence that we're gathering to make better decisions. So next 2 clicks, please. So what you see here is Nokia is traditionally seen in the communication space. We obviously have carrier space that we work with all the major carriers, but we also have a very large customer base in the utility space. But what we see now is we actually have been creating platforms because we see the need for this type of platform around artificial intelligence. We've actually created several platforms to help with the interoperability and the sharing of the information, as well as creating our new AVA platform to help with the intelligence-based decisions. So there's a lot of new things coming with Nokia, and it's not really a space that people realize that we're in, but we do have a great software team. And with Nokia Bell Labs, we're able to create some new algorithms and create these new platforms for the utility space as well. Next slide, please. So what I'm focusing on right now is one specific use case where we used what we refer to as sensing as a service, and we've enabled our customer to actually create this marketplace for data that they were able to gather. So we looked at the infrastructure sensors, some environmental sensors, and then sent that to our platform where we did the automation to make some suggestions and applied an algorithm that determined which generation source was the best one to use at that time or for that day. So if you're looking at environmental sensors, weather forecasts, and things like this, the site could then make the determination whether to use the battery that's at the site, or the on-site generation sources, or whether to use the grid, and which one would be more economically efficient. This data that they gathered was then put into a sales portal or database platform, where it's a publish and subscribe type of platform where other users could buy this data and use this same data to make similar types of predictions and make similar decisions. Next slide, please. So the goal really, again, was to manage the cost effectiveness of moving between these two sources, and this is something we see a great deal of with the number of distributed assets that are going into the field and connecting to the grid. This is going to be more and more useful, I guess, from a consumer standpoint, not only from a residential consumer, but an industrial consumer, to help manage their energy costs. So once the platform was up and running, the service provider actually that was running the system had access to the data site, and they were able to collect the data, but also take actions. And the actions is an interesting dynamic, because we don't think about necessarily making major decisions on the grid without some human intervention. And so I think the future of this will be very interesting indeed. Next slide, please. This really is just a snapshot of what that gen set looked like, of what we were monitoring at the site, the power dispatch, the fuel level, and some of the other, like the generator that was there, the fuel level, and then some of the alarms at that site. Next slide, please. So this really is where we're going. I want to really spend a little bit of time on this, the last couple of minutes on this, is we have a lot of things, proof of concepts that are being looked at, that are being identified in the challenges, as other people have mentioned. We really work around what is the challenge, what's the problem we're trying to solve. And I think that artificial intelligence really has a very broad base of application, I guess, even in the power utility space. When we look at frequency and phase management, again, tying it to the distributed assets and the variability of those assets in the grid, that's going to be very, very key to maintain grid stability. When you look at the energy market forecasting, and I'm very honored to be working with Aalto University on several different use cases right now, and this is something we have been speaking about, is the ability to create a market where you have individual users that could be participating, and being able to, for the aggregators, being able to market where is my energy going to come from, how much can I contribute to the grid, is going to be very key as those economic changes come about. Operational safety and security, obviously, being able to predict predict the asset maintenance is very, very important, but also the operational safety of a site. Being able to use video analytics and streaming analytics augmented with AI in order to say, there's a trip hazard, here's a transformer that's overheating, there's another hazard over here. There's things that we could do just from an operational standpoint as well. And then obviously the power reliability and maintenance, being able to make the grid smarter and act on its own even more so, is going to be very key for the future of the grid. So this is all really I had. Next slide, I think, is the end of it. So I really appreciate your attention and allowing me to contribute to the conversation today. Thank you. Back to you.
Thank you so much. It was very interesting to hear also the Nokia views. And once again, thanks to all speakers for sharing your knowledge with us. And it's time to move towards some questions and answers. And first, I have some more general questions. First one is actually targeted mostly to Vincent Debussy, Ilkka Lakaniemi, and Michel Morin, who are representing the academic point of view. But what do you think about the issues in France and Finland? Are we sharing the same problems concerning on AI in grids? You could probably start, Vincent, and then Ilkka and Michel, please continue.
Yeah. So thank you for that question. What I had in mind would be, in fact, data availability and data access. I have the feeling that in Finland, people would basically trust by default authorities with their data. It seems that almost everything is doable online, including administrative stuff and I would say life impacting actions. In France, you have a lot of cautiousness around that aspect. Privacy is a subject rapidly creating division, passionate debates. It's one of the main arguments of people still fiercely opposing to the deployment of smart meter, for instance, and as well part of the starting debate on 5G, even if recently cut down by our president. So in that context, I think AI is at the core of, I would say, phantasmagorical image of like dangerous paths or whatever. So basically, I would say in France, the understanding of intelligence tool by users and market and network operators, if we focus on grids, is an issue that will need care, notably by the AI expert, pedagogy and communication. On a more technical aspect, I would say stability under failure seems to be another big issue, simply because if you want to predict catastrophic or just drastic events, well, you need to have an history with a lot of them, which is great and not that much available right now. So it means that the stability of the prediction just after a difficult event, typically on grids, is something that we do not have that much a solution to for the moment.
Thank you. What about Ilkka? Do you have something to?
Yes, many thanks for the question and reflecting on the discussion that we had. The presentations that I heard and then also knowing where we currently are within Europe in thinking about smart grids through the EU activities, for instance, I think from the technology point of view, there are not that many differences. I think I already reflected that a little bit. Obviously, the cultural motivations and things that were reflected by Vincent are there, and we need to take them into account when we think about joint activities and joint work on this. And I think I can say on the fact that when you think about the role of data and AI and people's willingness, now I'm talking about individuals as consumers and then also the business people in their relation to data. There is a lot of work, even in Finland, still to be done in there for them to understand that the added value of data and how to realize that in the business operations. But luckily, I would say that through the testbed activities that we have done within Smart Otaniemi. We are currently moving into a phase where we are discussing with businesses moving from pilots to actually mainstream business and deploying those solutions that we have tried into their normal business practices as well. So I think we are on the way to more scaling in that effect.
Thank you. And then also, Michel Morin, you are an OECD specialist and probably have an idea about this as well. Would you like to share some ideas?
Yes, of course. From my perspective, mainly, I think the situation is probably the same between France and Finland, mainly because the problem we are facing are the same, and the main problem is the complexity of the network and the grid, and the more data we put in, and the more data we get from it, and the more, in a way, complex it comes, because it gives a lot of levers of actions. And the question is, how can we have visibility on what to do and what would be the impact, and so on and so forth, so to optimize it. So I think we are facing the same problems. And the main problem, as it has been said by one of the speakers, is that the problems we are facing are too hard, too difficult for our own brain. I mean, we are not smart enough. Each of us, I'm not talking about the other, I'm putting myself first in this limitation of intelligence. And so we need tools for helping us. And artificial intelligence tools, we talked about data, about knowledge AI tools, any of them are here to help to augment our individual and collective intelligence so that we can make decisions. And I think this is shared in Finland and France. However, what may be different can be the acceptability by the professional people working with in grids and in smart grids, in the DSO, TSOs, and all the players, to accept these tools, because sometimes they can be afraid of maybe the tools are going to replace them. And I think we experience that we have. It's very important to explain that the tools are not here to replace people. It's to give people more power, more information about the decision to make, about the impact of the decision, and so on and so forth. So I think there might be sometimes some people are scared, and maybe this is different in France and Finland. What is clear is that sometimes in France it's quite strong, and we have to prove that it's to enhance, to help them make better decisions, that these tools can be used. That's what I could share with you.
Thank you. And our next question is targeted to DSOs. So Mikko and Jean-Philippe, it would be interesting to hear how your companies work with SMEs and startups as well. As we know, this artificial intelligence is still quite a new thing in the business. So there is lots of SMEs and startups looking for opportunities. So
yeah, maybe if I'll go first. Yeah, we've recognized that we cannot do this alone, and even need all types of partners, small and large. Especially on the innovation side, we recognize that the smart innovations come from startups and smaller, medium enterprises, and we have quite many ways to handle this. First of all, we have this investment arm called Helen Ventures, who is investing in startups in Europe, not just in Finland. They've made a couple of interesting AI-related investments already this year, and are discussing with a lot of startups in this area. And then on top of the investment side, we are of course looking at the different startup companies. In October we had this innovation challenge, data-driven innovation competition, where we invited, or it was an open invite for startups and even bigger companies to participate. And we had 35 different competitors, and we selected 6 of them to our two-week like a hackathon. It was not product hackathon, but it was a concept hackathon and then we chose one of the contestants to start building a POC with us. But that's just one example. We are of course looking at startups very eagerly, and we know that they can help us in our journey.
Thank you. And what about Enedis? Do we still have Jean-Philippe online?
Do you hear me?
Yes, now we can hear you. And now we cannot. As we're running in a pretty tight schedule, I will suggest that we move to the next question, which is a bit more of a general question, but we would especially want to hear some ideas from Nokia and Nuka Solutions. So what do you think are the next opportunities in the field of AI? Perhaps.
I was just going to mention that. So I really see from my perspective, I really see the idea of the economical impact and the predictability and the forecasting of energy markets. From my stance, working in the energy vertical, that's where my focus is. So to me, that's where I see the most advancement in AI coming in, is being able to, for example, the interconnectivity between the European countries and the data that's going to need to be shared to create these types of markets where it may not be day ahead forecasting, it may be hour ahead forecasting. And so I see that type of integration in these micro markets and macro markets really having a large push on developing AI.
Yeah, and if I comment on kind of from my perspective and how we look at things. So basically we look at things from HVAC perspective, and as I was mentioning, we have seen a lot of development in this field, that there's a lot of new solutions related to ventilation process in the buildings and how artificial intelligence can automatically optimize certain ventilation process in the building. But we also see that there are solutions related to the heating of the buildings and also the cooling of the buildings. So I think we will see more solution in all of those areas, and I think there kind of the utilization of renewable energy sources in the buildings and kind of and batteries. So the whole kind of ecosystem and smart grid and the whole optimization of this with AI. I think that's something that I see that will happen in the future in this building and HVAC domain.
Thank you for the answers. That was my general questions, and during this webinar, Valerian has been collecting questions from the chat box. So I will give the turn to Valerian. Please go ahead with the questions.
Thank you, Tuti. There is a first question to Vincent regarding the sovereignty of the data. So Vincent, what about this sovereignty, especially regarding data storage and ownership? It seems to be today more located in the US. What can you say about that?
Yes, so that question was a good one. Thank you, Fabien. In fact, basically, AI techniques, you have to train them. It is costful in terms of energy, time, money. Big tech companies already propose pre-trained AI or advanced forecasting tool, of course. But it's not impossible to implement techniques on our own as well. So from scratch, I would say, to train them on our internal data. So basically, go around that problem of sovereignty. Because I've seen that somewhere in the chat, I think it's true. Once the data is on a server in a country, then you have to follow the laws of that country. So basically, either you know where your data is in what country and you are the owner of those data, or you have to deal and play by the rules of the country. So basically, coming back to making your own, in fact, data processing, AI training with companies of your own country, French in our case, or Finland, then would be an interesting way of increasing the competitivity of our national industry, I would say. Possibly having to redo things that are sometimes done by others, but it is not a loss of time, in my opinion, typically because we just increase our expertise as well, and the benefits are much more rewarding in that context, I would say. So yes, sovereignty is a problem, but there are solutions that in fact just require to go discuss with the academics in our country that are well prepared to deal with such issues.
Thank you, Vincent. Maybe, Michel, you have also some ideas about that. Maybe this topic of sovereignty of data are also discussed in your OECD group.
Yes, yes, of course. It's a very important aspect, the sovereignty of data. And if I want to just enlarge a little bit the subject, the question of ethics behind it's of course questions of business, but it's more generally question of ethics related to the use of data and the bias and all these questions. And of course there are possibilities, and as it has just been mentioned, there are possibilities that can arise to manage this, depending on where the data are stored. But there is more generally a question about how to deal with the data in an ethical perspective, and considering the whole AI system, the AI system as a whole, not only a bit part of the data, but what is going to be done with it, how it's going to be curated, how it's going to be used, how it's going to be checked that the decisions made with the data or ethical decisions do not introduce bias. And for that, you have to take into account the whole AI system. It's not just the question of data, but it's everything you're going to build from them. And there are a lot of recommendations, in particular by the OECD, about the way to manage that, the way to put processes in place. There is no 100% way to be sure that nothing is going to happen, nothing bad is going to happen. However, there are a lot of processes that can be put in place regarding the whole AI system that can allow to secure and to ensure this security and ethics in the use of data.
Thank you, Michel. Talking about security, there is a question also to Ilka. So, Ilka, how do you ensure the privacy of the data platform?
Yes, I guess you can hear me now. Yes. Actually, prior to going into that privacy question, I would like to take a stab at the technology sovereignty as well. So here in Finland, outside of the smart Otaniemi work, we have actually, together with the Federation of the Finnish Technology Industries, been working on guide on the ethical use of AI in business purposes. And that guidebook is currently being rolled out for the European Commission as well, to be a kind of a practitioner's guide on how do you utilize data in your business processes overall. And I'm happy to say that we will be kind of a scale to other EU countries as well. The issue there on data and security and the privacy side is of great relevance in that sense that when I talk to the business leaders of the companies, they are extremely cautious about sharing the data. So what it is that we have done is that we have actually built methods and tools for them to allow for peer-to-peer exchange of the data without that data being copied in any of the cloud services that they're currently using, so that it will not go into the big tech clouds, but they can have a secure transactions of the data for the pilots. Furthermore, we are educating the existing workforce of the participant companies through something we call the Data Science Campus. So that primarily the employees of Fortum, for instance, are together with data scientists and data engineers working on the type of solutions that will upskill and reskill their activities. So when Vincent was saying that we can use alternative tools, we are educating the people to utilize those alternative tools and actually to come up with their own best practices for the respective companies. So that's my answer there.
Thank you. Is there any more questions, Valerian, or?
Yes, sure.
Yes.
There was also a question to Ilkka about the next steps about in Smart Otaniemi. What about the new use cases bringing additional intelligence and artificial intelligence?
Yes. So the list that I didn't have time to go into in more detail was exactly that the existing use cases that we have had in the first phase will continue, and then we'll be looking into EV charging and the prosumer side in more detail. But at the same time, we are actually now inviting the companies that are participating in the Smart Otaniemi, the existing companies and the new ones, to actually approach us with new use cases as well. And some of those use cases are very much focused on when we had the DSO presentations on the maintenance side. So we are currently working on utilizing of advanced analytics in optimizing the maintenance and the spare parts distribution. So that's one example.
Thank you very much, Ilkka. I can see that maybe now Jean-Philippe Poirier can speak. So Jean-Philippe, if you can answer to the question about how you work with the SMEs and startups, and maybe it will be the last question.
Thank you. Do you hear me now, correct? Yeah?
Yes.
Very, very good. Well, I was saying that, thank you for letting me answer this question. We're fortunate enough to have some in-house data scientists within Enedis. But we are fairly open, and actually we're very open to have a diversified approach. It's all a matter of procurement strategy, but also when you get a startup or a small business that has a disruptive technology, we are not in the business of trying to do better. We are in the business of having a time to market that is reduced, and we're very open to work with such a startup or a company to make sure that we are benefiting from all the advantages that are provided by their solution as quick as possible. Thank you for your attention. Thank you, Valeria, and back to you.
Thank you so much. As we are having a couple of seconds left of our original time, I would like to thank everyone for joining us in this very informative and interesting meeting of 1.5 hours. We have heard lots of interesting presentations and got some answers to our questions. But in case you have any questions left, please don't hesitate to contact us, and we will continue the cooperation and send you all the materials so you can get back to them afterwards and also share with your friends and colleagues. So I wish you all very nice weekend, and hopefully we'll see each other in these webinars in the future as well. Thank you.
Thank you.
Thank you very much.
Thank you very much. Everyone, have a good weekend.
Thank you.